Good afternoon, everyone. It is my pleasure to welcome all the participants for today's session. I heartily welcome our speaker, Dr. Mala Kalra, our principal investigator, Dr. Varinder Garg, our co-principal investigator, Dr. Harish and Dr. Surinder Rana, Dr. Sakshi from UIT, and all the coordinators from our Brain Trust Institute. Today, we have a session named Cloud Computing, a New Path Provision in Healthcare. This session will give you insights how cloud services enable users to store files and applications on remote servers and then access all the data via the internet. Before we start the session, I would like to play one video of CIBioD. Please have a look.
So, hello everyone. Thank you so much for seeing this video. Now, talking about CIBioD stands for Center for Innovation in Biodesign, and which is a platform funded by ICMR and situated in PGIMR Chandigarh. It promotes innovation in medical devices and instruments by creating a conducive an ecosystem with the involvement of multiple premium technological institutes in collaboration with PJM. India has achieved a tremendous amount of progress in the field of IT. However, we are still lagging behind areas of innovation and research in healthcare. CBAD aims to fill in these voids in innovation research in Indian healthcare sector. Now, talking about the objectives which we share, the objectives which we share are that is innovation in the biodesign of medical devices, instruments, technologies, including life sciences and other branches of healthcare for making healthcare affordable. Automated solutions and approaches for various common medical problems, manpower training for researchers, and providing a hub of consultancy center uh, that provides solution to hospital businesses in the area of medical science. Now, talking about the short-term attachment program, which we call as Arogaya CIBioD short-term attachment program, it has been a golden opportunity for students, researchers, and faculties. And some of the salient features of the attachment were that is learning about uh, innovation, incubation, prototyping, clinical validation, and commercialization of ideas in affordable healthcare. And primary areas of learning will be in the uses of technology. And also, there are some specific modules which are being very specific to the domains in the area of medical sector and healthcare. Personal interaction program will be also provided with the experts of medtech industry. An opportunity will be provided to work on the development of prototypes with the expert teams, and the certificate will be given at this after successful completion. Now I will be handing over this to my colleague.
For today's session, our speaker is Dr. Arogaya. He is working as an assistant professor in Department of Computer Science and Engineering at National Institute of Technical Training and Research, Chandigarh. She has completed her bachelor's and master's in computer science and engineering and have also added her PhD in the same from Punjab University. She has more than 17 years of experience in teaching and research department. Also under her mentorship, 35 students have completed their masters and 2 PhD students' theses are in the line. She holds over 50 research publications in reputed international journals and conferences. Additionally, she is a reviewer of several journals like Elsewhere, IEEE, and Springer. Her core interest lies in cloud computing, IoT, and data analytics. And with her experience of 17 years, she is a lifetime member of Indian Society for Technical Education, Computer Society of India, and lifetime fellow member of IEEE. We welcome you, ma'am.
Am I audible?
Yes, ma'am.
Okay. So thank you, Rima, for the nice introduction. Also, I thank the coordinators for providing me this opportunity to deliver the session. Can I share my screen?
Yes, ma'am.
Is my screen visible to all?
Yes, ma'am.
So to continue with this session, I would like to say that I would be demonstrating or I would be describing the cloud computing. Initially, I'll be giving the basics of cloud computing. Then I'll be discussing the basics of healthcare. That means I'll be demonstrating the framework of healthcare. And then I'll be discussing the role of cloud computing in healthcare. And at the end, I would be discussing the advantages of using cloud with respect to healthcare. So what is cloud computing? It's the delivery of computing resources. Computing resources can be servers, storage devices, or it may be software applications. Usually, these computing resources are delivered over the internet. That means internet will act as the communication medium for accessing these resources, and these services will be accessible on a pay-per-use basis or pay-as-you-go basis. Pay-as-you-go basis means you'll be charged based on the amount of computing resources that you will be using. So for an example, if you are hiring the computing resources from Amazon Cloud, which is called as AWS Cloud, so in that case, as per their standard rates, let's say they are making you available the computing servers on the basis of $1 per hour, and you are hiring the servers for, let's say, 3 hours, then you need to pay $3 because you have used the services for 3 hours. So it is pay as you go basis. That means you have to pay as per the amount of usage of computing resources. So as per the definition of a standardizing body, that is NIST, National Institute of Standards and Technology, it's a model for enabling ubiquitous, that means which is available, which can be accessed from anywhere, convenient to use, on-demand network access to a shared pool of configurable computing resources. On-demand means whenever you'll be requiring the resources, you can just request the resources from the web portal and you can access the resources. And as the resources are available over the internet, that's why we are saying on-demand network access to a shared pool of configurable computing resources. Actually, the resources are shared between multiple users, because a physical server, the whole physical server will not be allocated to a single user. Instead, the physical server is virtualized. That means virtualization is applied on the physical server, and multiple virtual servers are created on a single physical server, and those virtual servers are allocated to individual customers. That's why we say that you'll be accessing the resources from a shared pool of configurable computing resources. And again, computing resources may be servers, storage, and applications that can be rapidly provisioned and released. That means as soon as you request for the resources, you will be allocated the resources, and when you no longer require the resources, these computing resources, you can release them with minimal management effort or service provider interaction. That means every time you need to get the resources, you need to provision the resources, or you need to release the resources, service provider interaction is not required. You do not need to interact with the service provider every time. Instead, they are providing you a web portal through which you can request for provisioning of resources, as well as when they are no longer needed, you can request for release of resources. So accordingly, you will be charged. That means for the time you have used the resources, you will be charged for that time period only, and after you have released the resources, you will no longer be billed. So cloud computing is storing your data applications on remote servers. That means on the servers of the cloud service provider, and that cloud service provider may be located in a different country, in a different region from your region. That's why we are saying that cloud computing is storing data and application on the remote servers, processing your data and applications on those servers, and accessing that data through the internet. So these are the 5 main characteristics of cloud computing, which are proposed by NIST, that is standardizing body. First is cloud computing provides on-demand self-service. On-demand means whenever you require the resources, you can acquire them. Self-service means human interaction, any kind of human interaction or interaction with cloud service provider is not required. You just have to access the web portal provided by them and you can request for the resources. just have to sign up, like I was talking about AWS Cloud. So you just need to open their website of AWS Cloud, and you just sign up on their website, and you can request for the resources. They'll be asking your debit or credit card details, so that whenever you are billed, whenever you'll be charged, they can deduct the amount from your respective cards. Resource pooling again means that you'll be sharing your resources with other customers, because as I've told you that the servers will be virtualized. So virtual servers, you'll be accessing one or two virtual servers from a single physical server, and that physical server is being shared with other customers also. That means maybe let's say one physical server is having 10 virtual servers, so maybe two of them are allocated to you, and rest of the virtual servers may be allocated to other customers. So this is resource pooling. That means you are sharing your resources with other customers. Broad network access means you will be accessing the cloud services via internet, and you can access these services using any kind of platform, like you can access the resources from laptop, desktop, or mobile phones. Rapid elasticity means anytime you can increase the number of resources as per your requirement, and if no longer required, you can release the resources as per your needs. Measured service again means pay as you go basis. That means the resources you will be using, those resources will be monitored, controlled. This is done to actually maintain transparency between the customer and the provider, because at the end you will be charged for the usage of resources. So they are monitoring the usage of your resources, so that at the end they can charge you accordingly. Now we'll be discussing the cloud service models. Service models means the type of service that you are getting from a service provider. So broadly, there are three types of service models: software as a service, platform as a service, and infrastructure as a service. Software as a service means you'll be getting software applications as a service. So application is hosted as a service to the customers. So cloud service provider will be responsible for maintaining the cloud infrastructure for you. That includes storage, network, operating systems, as well as the application platform. Application platform means the tools which they have used for building the application. That may be PHP, MySQL, that may be Java. So whatever tools they are using, they'll be responsible for managing those deployment tools, for managing the infrastructure. So they'll be responsible for managing the whole application, software application for you people. And you just access that application for your requirements. So these applications are accessible from various client devices. That means you can use either a thin client or a thick client, and using a web browser or a program interface provided by the cloud service provider. So the examples may be like you are using nowadays Google Docs, Google Spreadsheets, Gmail, etc. So all these services are being provided as software as a service, because you are just using these applications. You are no longer worried about how these applications are managed, on which type of infrastructure they are managed, how that infrastructure maintenance is carried out. So you are not worried about the infrastructure part as well as the application platform part. So these applications are managed by Google on their own cloud platform, that is Google Cloud Platform. So you are just accessing the applications. So these kinds of applications feature automatic upgrades and updates. If we compare it with other software products, like if we buy some software product, in those cases we need to ourselves manage the related upgrades and updates. But in these cases, the service provider is responsible for providing you software upgrades and various software updates, and all users will be using the same version of software in this case, because this is provided, they are providing one software as a service which is given to all the customers. So there is no matter there is no issue of incompatibility of software between different users, and it is being provided as subscription based service. That means you'll be taking means no longer need to buy the license of the software. You'll be taking subscription of the software, and if you are using it for 1 month, you just have to pay for 1 month. And after that, if you no, if you do not need that service, you can release the service. That means you can request that I am not requiring this kind of service onwards. Then comes the platform as a service. So in case of platform as a service, cloud service provider offers and manages software tools for the end user. Software tools again means, let's say you require some kinds of software tools for developing your applications, because in case of software as a service, you are getting the application, but sometimes what happens, that software, you feel like software is not customized as per your needs. Some companies feel that when they are hiring software as a service from service provider, they feel that some of the features they need, that those features are missing from this software. So that means software is not customized as per a single company. It is a general purpose software, right? So in those cases, what they can do, what these companies can do, they can take platform as a service from the service providers. So this means that they'll be taking application platform. Let's say they want to build their application in .NET, or they want to build that particular application in Java or PHP MySQL or any paid software. So accordingly, they'll be taking platform as a service from the cloud service provider, and they'll be building their applications as per their needs. So that application will be customized for that particular company, because they are building that application for themselves only, right? So in this case, cloud service provider will be offering software tools to the end user so that they can create and deploy their applications. Again, cloud provider will be managing the cloud infrastructure, including network, servers, operating systems, and storage. So again, there is no need to worry about the hardware maintenance to cloud service provider. End user again has control over the deployed applications, because the applications have been built by themselves, and they are according to their preferences. So they have full control over the deployed applications and possibly the configuration settings for the application hosting environment. That means the application platform they are getting from the cloud service provider, they have maybe somewhat control over the configuration settings of that application hosting environment, right? So these are some of the past providers like Google App Engine, Windows Azure, Longterm, Force.com. So these are providing a platform as a service. Then comes the infrastructure as a service. Let's say we just want servers only, or we just want storage devices only. We want flexibility. We do not want that some particular software tool is installed over that infrastructure, or some software already built software application. We don't want that kind of thing. We want the raw infrastructure. That means we want some storage devices, we want some servers. In that case, our preference is infrastructure as a service. So in this case, you'll be provided only raw infrastructure, that is storage, network, and computing resources. But you'll not be getting the full physical server. Again, they'll be managing the virtualization technology. That means using virtualization, they have already created the virtual machines over the physical host. So you'll be allocated these virtual machines, and if you require some storage devices, you'll be allocated storage devices as per your needs. Now you'll be getting the infrastructure, and if you want to build some website, or you want to build some other software application, like you want to build some software application for healthcare, then you can build as per your needs. You can install the required software, your required application platform, and over that you can build your own application. So the end user is able to deploy, run, and control the software, which may include operating systems and applications. The user can hire the infrastructure according to the requirements at any particular point of time. So instead of buying the infrastructure, you can just hire the infrastructure. Let's say the point here is that maybe your needs are varying monthly basis, like in one day, like let's say currently you are having a requirement of 10 servers or 100 servers. So at the current moment you can hire 100 servers. Let's say next month you are requiring only 50 servers because the workload is less, so you can release the rest of the servers. You can just keep with yourself only 50 servers. So accordingly you'll have to pay. So that's why we have written that instead of buying the infrastructure that might not be used for months, you can just hire the infrastructure as per your requirements at any particular point of time. Virtualization enables infrastructure as a service providers to offer almost unlimited instances of server. If they would have allocated the whole physical server to a single customer, so they have analyzed that resource utilization is very low. They are having lesser benefits, so that's why they have deployed. They have applied virtualization over the physical servers and created virtual machines, and in this way they were able to serve more and more customers, and they were able to achieve maximum resource utilization, and accordingly it was also cost effective use of the hosting hardware. IaaS is sometimes also referred to as hardware as a service, because in this case you are giving your customers the hardware only. It is really beneficial for startup or small businesses. Why? Because initially when you are going to start a business, or you are going to open a startup, so in those cases you may not be having the whole so much, you may not be in a position to spend on the capital expenditure or operational expenditure. That means initially you may not be in a position to hire a land for setting up your business. For you may not be in a position to buy so much servers which are really costly, and maybe you may be thinking of that maybe it will run properly or not. So keeping these things in mind, what you can do is initially you can hire the infrastructure from the cloud service provider by taking infrastructure as a service. And when you feel like that your business is running properly and you have earned a lot, and you need to set up your own business without hiring the infrastructure from the service provider, in that case you can buy a land and can set up your business over there, can buy the servers then. So initially it will be beneficial if you hire the servers from the cloud service providers. Moreover, it will be beneficial when the workloads are bursty and dynamic. That means, again, the point is that if your workloads are varying, means at one instance you are having uh, high workload, your websites is having higher traffic, but at other point of time, like next month, the workload is low, it is having lesser traffic. In that case you can take the services of cloud, and when you are feeling like the workload is more, in that case you can hire more number of servers, and when the workload is low you can release the number of servers as per the requirement. So in this case, cost savings will be significant, definitely. These are some of the well-known IaaS providers: Amazon, Rackspace, GoDaddy. So these are Amazon is the most popular IaaS service provider. You can refer to their website as AWS Cloud. So this is the hierarchy. If you are taking infrastructure as a service, then you'll only be getting the infrastructure. But if you are taking platform as a service, infrastructure and platform, both of the things you'll be getting. and you are taking software as a service, you'll be automatically getting the infrastructure and platform in addition to the software. But in this case, you can only have control over the software applications. You will not be in the case of software as a service, you cannot change the platform or the infrastructure. Means these configuration settings will not be in your hand. Next comes the cloud deployment models. So deployment models basically refers to the location and management of the infrastructure. So based on the location and management of the infrastructure, we are having 4 deployment models, that is private cloud, community cloud, public cloud, and hybrid cloud. So let's first of all talk about private cloud. So these types of clouds are operated solely for an organization. So it may be managed by the organization or a third party. It may exist on premise or off premise. Let's say a company A is there, and this company does not want to share its resources with other company. So this kind of scenario means sharing of resources happens in case of public cloud. If you are taking the services, computing services from a public cloud, as we have just talked, that in that case, your resources are shared with other customers. But if you are having some concerns, security concerns, that you are working with an application which is really sensitive, or you're working with some data which is quite sensitive, so you may be needing a server which is not shared with other customers. So in that case, you can hire the services of private clouds. So this type of private cloud will solely be operated for a single organization. The infrastructure in private cloud will not be shared with any other organization. So you can basically build this type of cloud in your campus. If you are you can spend so much, because this type of cloud is not cost effective. This is quite costly, because in this case you need to buy the whole infrastructure as you do in case of on premise infrastructure. So you need to buy the whole infrastructure, you need to manage the infrastructure, everything. For everything you will be responsible. So one option is that you can build such type of cloud in your own campus, but in that case you need to look after everything for maintaining that cloud. Other option is that you can take the services of third party. For example, Amazon gives you an option of Amazon VPC, virtual private cloud. In that case, they will be providing you infrastructure which will not be shared with any other organization, so that you can process your sensitive data, keep your sensitive data on the private cloud. So this type of cloud is not cost efficient, because this will be run for a single organization, but it has a tremendous value from a security point of view. That means if you want to run the applications which are quite sensitive from security point of view, then you can hire the services of private cloud. And in this case, the security concerns will be addressed through secure access VPN. If you are taking the services of private cloud from a third party, and they are managing your private cloud in their own location, or if you are managing the private cloud in your campus only, like the on-premise infrastructure, so in that case you can protect your private cloud using firewalls. So this type of cloud is really beneficial for highly sensitive data and applications. So if I take an example, like if we talk about healthcare applications, so you know that the patient data is needs to be uh, kept confidential, means it's very secure. It's need to be very secure. It is very sensitive. So in those cases, healthcare organizations can have the services of private cloud, or if they are having so much, they can spend so much So they can build their own private cloud also. So in addition to security reasons, this model is adopted by organization in cases where data or applications are required to conform to various regulatory standards. As I was talking about healthcare organizations, so in USA, healthcare organizations, pharmaceutical organizations which are dealing with sensitive patients' data, they need to abide by some regulatory standard. That is, they need to abide by HIPAA Act, that is Health Insurance Portability and Accountability Act. According to this act, they need to means they have to keep the patient data very much secure. They cannot store this data at any unknown location, right? So in those cases, they can take the services of private cloud. So this is what is mentioned over here, that moving data to the cloud for some healthcare and pharmaceutical industries may violate these kinds of norms. So this is the act which they need to follow, and this is set as a standard for sensitive patient data protection. So companies that deal with protected health information must have physical network and process security measures in place and follow them to ensure HIPAA compliance. So even if these types of organizations do not are not in a condition to set up a private cloud or to hire a private cloud because of expenditure issues, so in that case they can look into the norms of the look into the service level agreement of the cloud public cloud providers. Like in case of Amazon, they ensure that if healthcare organizations are going to store their data in their cloud, they ensure that the data will be stored in accordance to HIPAA compliance requirements. So then these types of organizations, healthcare organizations, whenever they need to store these kinds of sensitive data, they have to ensure that the cloud service providers are abiding by HIPAA compliance requirements. Then public clouds, these types of clouds are made available to the general public or a large industry group and is owned by an organization selling cloud services. So that means I'm talking about Amazon cloud services. So that they are generally offering public cloud services. That means their infrastructure is available for the general public, for all the companies. Anybody can hire the services of the AWS cloud. So again, the resources will be shared between multiple organizations. So this is actually representing the true cloud hosting. And this type of model is best suited for businesses who need to manage load spikes. Means again, if the load is varying, then in that case, public cloud is the best option. And it is required to manage applications which are going to be consumed by many users. So that would otherwise require large investment in infrastructure from businesses. That means if they are having applications which needs to be consumed by several users, then this kind of platform is beneficial, because everybody can hire the infrastructure. Means if multiple users want to access the services, they can access the services through the internet. So this type of model helps to reduce the capital expenditure as well as operational IT cost. Capital expenditure means the expenditure related to buying the land, etc. And operational IT cost means the cost related to the salaries of the employees or staffs, etc. Then comes the community cloud. So cloud infrastructure is shared when it is shared between several organizations which are having similar type of concerns. Let's say if we are talking about healthcare organizations, let's say there are three healthcare organizations. They want to collaborate over patient data or many other similar types of things. They are having similar type of security concerns, policies, compliance considerations. So what they can do is, rather than individually hiring the services of private cloud. Like if A is hiring the services of one private cloud, B is hiring the services of another private cloud, C is hiring the services of another private cloud, which is going to be quite costlier. So rather than doing this kind of thing, what they can do is they can share a share the services of a community cloud. Means they can maintain, they can build a cloud which whose infrastructure can be shared between these three organizations. So benefit is that it will be cost effective as comparative to private cloud, as well as this type of through this type of cloud they can share the data, they can share the applications of their concern. So this kind of cloud can be managed by these organizations, or they can hire a third party to manage this type of cloud. So this type of cloud infrastructure is beneficial for organizations which are having same policies and compliance considerations, as I've taken an example of healthcare organizations. So this helps to further reduce costs as compared to private clouds, as it is shared by larger group. Again, various hospitals requiring access to patients' data can utilize this type of cloud to perform collaborative research or access EHRs. Soon we'll be discussing what are EHRs. Hybrid clouds. So sometimes the organizations want the services of the different types of cloud at the same moment. Like if an organization is there, this organization wants to keep its sensitive data on its own private cloud, right? But it is having limited infrastructure. So if it wants to process its data and applications which are quite huge in size, so these types of applications and data cannot be processed by this private cloud. They want scalability. So in that case, if these applications which are scalable, they are no long they are not security, means they do not require that much security, so they can be put on public cloud, right? So that means they are taking the services of private cloud as well as public cloud. And the thing is that in this case, they are having some, they want some kind of technology so that which enables the data and application portability between private and public cloud. That means if they want to transfer some kind of some data or applications from private to public cloud, it should be possible, or some data or application from public to private, it should also be possible. So that means this kind of cloud infrastructure is a composition of two or more clouds, that may be private, community, or public, that remain unique entities, but they are bound together, linked together by some kind of standardized or proprietary technology that enables data and application portability. So this is the most important point here, data, and it is enabling them to uh, have data and application portability. So this deployment models helps businesses to take advantage of secure applications and data hosting on private cloud, whereas still enjoying scalability and cost benefits of public clouds by keeping shared data and applications over the public cloud. And this kind of cloud is also allowing you to migrate workloads between public and private clouds. So for example, an organization might want to use a public cloud service like Amazon S3 for archive data, but it wants to continue with its own in-house storage for operational customer data. Now I'll be discussing a general framework of smart healthcare system. So at the lower level, the first step in a smart healthcare system is the data collection. That means we need to collect the patient's data. that may be collected through physician observations. That means whatever prescription has been given by the doctor, laboratory test results, lab reports, some genetic data if it's there, historical records, demographics means patients, personal details like age, etc. So in this case, data may also be collected using chatbots. So the very first step is the collection of data, patients' data. And then this data is managed in the form of electronic health records. Electronic health record is the systematized collection of patient health information which is stored in a digital format. Because earlier, as I was talking you, physician observations, so this kind of data may not be in digital format. Maybe somebody maybe some doctor has written a prescription on a prescription slip, so that needs to be converted into a digital format for maintaining the electronic health record. That means this kind of application is going to store all the patient's health information in a digital format. So patient health information may contain his medical history, diagnosis reports, earlier diagnosis reports, medications, treatment plans earlier given to that patient, immunization dates, allergies, radiology images, laboratory test results. Means it is going to store everything, every health information related to a patient. And the benefit is that this kind of information can be shared across different health organizations. So these EHRs are further going to be used in clinical decision support systems. So what are these? Clinical decision support systems are programs that use machine learning algorithms to analyze data within EHRs to further help the clinicians, that means doctors, in their complex decision making processes. So here decision making processes means, let's say he wants to doctor needs to take a decision with respect to diagnosis, with respect to some treatment plan, with respect to some disease risk monitoring or prevention. So in all these decision making processes, this clinical decision support system is going to facilitate him. So if this kind of system is applied to cardiovascular disease prevention, so it may help the physician by flagging cases of hypertension, by providing information on treatment protocols, providing tailored recommendation for health behavior changes. So this kind of healthcare inference is becoming possible because of the large amount of patient-specific clinical data and because of the use of these machine learning algorithms. So machine learning algorithms we can apply only if we are having large amount of data. So by using these machine learning or deep learning algorithms, we can analyze this large amount of patient data to derive healthcare inference. For example, deep learning algorithm known as convolution neural network has been shown to perform on par with 21 certified dermatologists in skin cancer classification. And this kind of application was able to classify or predict the skin cancer more accurately than these dermatologists. Disease prevention and risk prediction. So by using these clinical decision support systems, we can prevent the diseases in the persons, or we can predict the risks. So data of the patients, of the persons may be collected through wearable medical devices, and this kind of data may be uploaded to cloud. Data may include patients' genetic information and historical records. So that means we are going to collect numerous patients' data, and the data may be their daily regular data, like their heartbeat rate, their blood pressure. Using, we can collect this kind of data using wearable medical devices on daily basis, and we can also collect their genetic information, historical records. And by maintaining this kind of information and what kind of diseases they are having, what kind of lifestyle they follow. So if they are having some kind of diseases, using data analytics algorithms, these programs can predict that further, like if we are asking about new patients, new persons data we are feeding, so these kinds of algorithms can predict that what kind of diseases they can have in future by just being trained by earlier patients data. So how they work, actually these machine learning algorithm work, they are being trained with the patient's data which is already there, and what kind of diseases they were having. We can predict, these kinds of algorithms can predict that the patients which are coming now, if they are having similar kind of symptoms, if they are having similar kind of lifestyle with the earlier patients were having, so we can predict that they, what kind of diseases they can suffer from in the future. So these programs can help in preventing diseases such as chronic health conditions like diabetes, hypertension, high cholesterol at an early stage by adjusting their lifestyle. Then using this clinical decision support system, doctors can give expert advice based on the algorithms to improve accuracy of diagnosis, reduce the incidence of misdiagnosis. That means these algorithms, these the support system can help them to improve the accuracy of diagnosis. Earlier maybe there were some incidents of misdiagnosis, so that can be reduced, and patients may be able to receive timely and appropriate medical treatment. Further, after diagnosis, let's say somebody has been diagnosed with some particular disease, so doctors can predict more accurately which treatment will be suitable for a particular disease for a particular group of people. So rather than going with one size fit all approach, in which disease treatment and prevention strategies are developed for the average person, we can go ahead with precision medicine. So what is this? It's an emerging approach for disease treatment and prevention that takes into account individual variability in genes, environment, and lifestyle for each person. So what it means is that rather than giving a medicine, particular medicine to all cancer patients, which they used to give in past, doctors used to give in past, now they can give the medicine and after analyzing the genes, lifestyle, environment of a particular patient, and after analyzing these things, they can suggest the appropriate medicine. So rather than giving this medicine to same medicine to all the persons, they can first of analyze, the divide, they can divide the people into different groups as per their genes, lifestyle, and environment, and then they can suggest the medicine for that is appropriate for that particular group of people. So this is known as precision medicine. Then remote patient monitoring, which is making it easier for doctors to stay in touch with patients who are discharged from hospitals, who are suffering from chronic diseases like diabetes, high blood pressure, or dementia, managing people with disabilities, or aging populations. So that means the patients for whom it is quite difficult to come to visit the doctors again and again. So for those patients, remote patient monitoring is uh, quite comfortable. So in this case, the doctors can monitor the patients by using wearable devices. They can put wearable devices onto the patient, such as heart monitors, blood pressure monitors. So these devices acquire and transmit the patient data to the cloud for further processing. And after processing the data on the cloud, some kind of predictions can be made, like whether they will be requiring some kind of healthcare treatment in the future soon, or whether their health is okay. So these kinds of remote patient monitoring is quite helpful for doctors as well as for patients. So other wearable equipments can be wearables which are equipped with electrocardiograph sensors. These types of wearables can monitor the patient's heart activity by sensing multiple physiological signals. Some devices are also equipped with complex sensors such as electromyogram sensors that records muscle activity, electroencephalogram sensor that monitors electrical simulations within the user brain. So these kinds of devices are quite helpful in remote patient monitoring. Image analysis, that means the analysis of x-rays, MRIs, mammographies, which is usually done by radiologists. So data science algorithms are quite useful to interpret these types of images, and these algorithms helps in identification of the patterns in the data and detection of tumors, organ anomalies, etc. So these algorithms can diagnose irregular heart rhythms from ECGs faster than a cardiologist, and they can also clearly differentiate between images of malignant lesions and benign skin marks. So radiologists are definitely going to be benefit with regard to detecting and monitoring diseases with the use of these data science algorithms. So time and again we are talking about that nowadays data science algorithms are being employed in healthcare to in various applications, like in image analysis, like we have talked about remote patient monitoring, like in diagnosis and treatment, disease prevention and risk prediction. But at the back end, the infrastructure which we are using for running, for executing these data science algorithms, for storing patients data which is quite huge in size, we are requiring cloud infrastructure, because without using cloud infrastructure it is going to be quite costly, as well as will be requiring huge infrastructure for running these data science algorithms, which are quite computation intensive, sorry. So for running these compute intensive data science algorithms and for storing huge amount of patient data, cloud infrastructure is quite beneficial, because we are going to get almost unlimited storage devices from cloud, and we are going to get a lot of computation power from the we can get a lot of computation power from the cloud. So Google Cloud, Google is pushing healthcare specific services built on top of their Google Cloud platform. One of the example is APG, which offers API management as part of the Google Cloud suite. So what we mean by APG, and what is like API, what do we mean by API management over here? So I'm just going to discuss. APG aims to use FHIR to create APIs and enable interoperability. So what do we mean by interoperability here? Interoperability means like if different hospitals, physicians, and other healthcare organizations uh, want to share their data and want to work upon EHRs, so it is quite difficult, because the data is coming in different forms. Like one is giving uh, physician observations in one form, some other physician is giving its observation in other form, and that some of the data is in the form of images, and means data is coming in different forms, patient data is coming in different forms. To so how to means get useful insights out of this data, how to aggregate this data is very much difficult. So to increase interoperability among these organizations, among this huge data, the industry is slowly shifting to a new technology known as FHIR, that is faster healthcare interoperability resources. So basically this is going to create standards for different data elements so that developers can build APIs, application programming interfaces, that can be used to access data sets from different systems. If I say in simple words, then this FHIR is going to create a standard so that these data sets can easily be accessed from different systems. So APG is such an application which is being offered by Google on their Google Cloud platform. Another example is their G Suite services, which include Google Drive, Google Docs, etc. They are providing this G Suite specifically for healthcare organizations. So why we are saying that this G Suite is specifically for healthcare organizations? Because this G Suite is a HIPAA compliant cloud service, as we have talked earlier also, that healthcare organizations have to store their data as per HIPAA compliance requirements. So this G Suite is offering a HIPAA compliant cloud service that healthcare organizations can use to share patient information. So now the last part is the advantages of using cloud services in healthcare. First is that cloud services are quite economical, because when we are talking about storage of data in physical form, it is going to take lots of space, effort, and money. So we'll be needing a physical location with a big infrastructure and management team to store the files and figures accurately. However, with the use of cloud computing, there is no need to worry with physical locations in order to store your data, because you are going to hire the storage devices which are placed at cloud service providers location. You just need to hire the infrastructure and you can place your data over there. And the pricing is also nominal. You can hire the servers also for running your data analytics program. Even they are providing you healthcare applications like cloud-based EHRs. They can provide you as a software as a service. Then again, the cloud service provider is responsible for hardware and software maintenance. So you don't need to worry about hardware maintenance and software updates. Online collaboration is possible, like we were talking about EHRs. So if EHRs are maintained by cloud service providers, they are providing it software as a service. So the different physicians from different hospitals, from different healthcare organizations, they can easily collaborate. Better data security, definitely they are going to provide you 24/7 security for your data. Most of the like Amazon is there, they are also providing you HIPAA compliance for storing sensitive patients data. Saves time, because why we are saying it saves time, because in this case it is going to provide you quick access to accurate and updated patient data so that they can prescribe medications accordingly and timely. Faster speed, huge servers they are having, so they can provide you those huge servers as per your request. And the faster speed of cloud computing keeps it one step ahead of other storage services. That means they are going to provide you rapid access to data upgrades and updates with faster speeds without any human intervention. Reliability and scalability, if you're going to store your data in cloud, they are going to replicate your data on multiple servers, so that in case some kind of disaster occurs, so that kind of data, your data can be accessed from some other region, from other servers. Whereas in case you have stored your data uh, in your own premises, and if some disaster happens, then you can no longer access your data. Scalability, the need for storage space and data access can anytime be increased and decreased in accordance with the demand of the hospitals. So cloud computing technology is reliable as there is no issue of data theft, downtime, or unauthorized information leaks. So that is all about my side. Thank you all for patience listening. If you have any queries, you can put on.
Students, if you have any queries, then you can ask our speaker.
Good afternoon, ma'am.
Good
Raymond this side.
Yeah.
Thank you for such a great lecture. I had a doubt
Yeah.
that how do virtual machines work?
How do virtual machines work? They work in the same way as the physical machine, just that we have a layer of virtualization over the physical machine, and we are calling it as a virtual machine. That means you feel like you'll not feel like it's something different. You'll feel like you are working on the physical machine, because you'll be provided the required infrastructure, just that the physical machine is shared between multiple virtual machines, right?
Okay, ma'am. Thank you.
Anyone else? I think, ma'am, students don't have any doubts.
Okay, thank you. Thank you.
Thank you so much, ma'am, for sharing such a wonderful presentation. I deeply appreciate the topics you have shared with our attendees. Hope this session will benefit a lot to our students. Thank you once again, ma'am.
Thank you all. I hope students have gained a lot, and the session was fruitful for them. Thank you all.
Students, please fill the feedback form after the session. Okay, goodbye. Take care.
Can I lead the session?
Yes, ma'am.